Pre-Calc section 4.2. It is time to start putting it all together. Okay, so this is what we've all been waiting for. We are going to write polynomials in factored form. Very fancy factoring. And here's the steps. Step 1, you make a list of PRZs. Step 2, you test them with synthetic division. You try to find the one that works. Once it does, you find all the zeros by factoring over the real numbers. Okay, let's do that. Step 1, we need to make a list of PRZs. So in the numerator, you put all the factors of 10, plus and minus 1, plus and minus 2, plus and minus 5, plus and minus 10. In the denominator, we're going to put all the factors of 5, plus and minus 1, plus and minus 5. Now we have to make every single possible combination, so dividing them by 1 gives us plus minus 1, plus minus 2, plus minus 5, plus minus 10. And now let's divide by 5. So we have 1/5. We have 2/5. 5 divided by 5, I already have 1 and I already have 2. These are the only possible numbers that are going to work. So when you're testing numbers, all the numbers in the world, should I try 3? No, 3 definitely won't work. Of all of these, not all of them will work either. So it's time to try. Let's start on the left-hand side and work our way up to the fractions, right? So we'll start with 1, and the coefficients are 5, negative 22, negative 17, and 10. Okay, here we go. Drop down 5. 5 times 1 is 5. Negative 17. A negative 17 and negative 17 is negative 34. Oh, that is not working. Okay, 1 does not work. Let's try negative 1. Some people say, well, can't we try 2 first? Yeah, you could try 2. I think I just want to work in order. 5, negative 22, so the coefficients from before are still the numbers we're working with. We've got 5, negative 5, negative 27, a positive 27, positive 10, negative 10, 0. Okay, stop. As soon as you find one that works, what are you supposed to do? You're supposed to write f of x in factored form. The factor that we found, the 0, is negative 1. So the factor is x plus 1. This polynomial, when we started, was x to the third. When you take out a single power of x, it's always 1 power less. So my divisor here, or the quotient rather, is 5x squared minus 27x plus 10. Okay. Now, we've only taken out one factor. We still have 2 more to go. And here's your options. Testing, 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 or can we just factor this by hand? If you can get it factored by hand, it would be a lot faster. Let's see, does this factor? The only way to make a 5x squared, the only way is with a 5x and a 1x. Now what about 10? 10 and 1, it could be 2 and 5. I need to make a 27. Well, if I put 5 here, 25 plus 2 more, and if I do negative, negative, perfect. So what are, let's just put a box around our answers here. What are the zeros? I knew the first one was negative 1. I found that with my synthetic division. This 0 is 2/5. So we would have had to do a lot of testing. That answer's all the way down here. And the last one is 5. All 3 of them are on the list of possibles. So I guess there's no 10s that work. Okay. Let's see. F of x was 5x to the third when we started, and it still is 5x to the third. What does a graph of this polynomial look like? Well, I need to touch the x-axis at negative 1, 2/5, and 5. How about a y-intercept? The y-intercept might be really easy if we look back at the equation in polynomial form right there, standard form. The y-intercept is a 10. So here's 10. This is x to the third, so the end behavior is going down and up. And it seems like the multiplicity is odd for all of them. So the graph is going to cross, 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 go up. Okay, so we're putting together graphing polynomials from the beginning of the chapter along with getting these things in factored form. All right, number 2, write f of x in factored form. So the steps are make a list of PRZs. Make a list of PRZs, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, and we're going to divide by plus and minus 1. If you divide by plus or minus 1, I think we're just going to get that list right there. Okay, so I did consider the denominator, but I'm done. All right, I'm going to start with a 1. And our coefficients are 1, negative 1, negative 7, 1, and 6. Okay, ready, Freddy? Here we go. Drop down 1, 1, 0, 0, negative 7. Negative 7 plus 1 is negative 6. I found a winner. As soon as you find one that works, what are we supposed to do? Write f of x in the new factored form. Write the factor and write your quotient. X minus 1. This was x to the 4th, so now we're down to x to the 3rd plus 0x squared minus 7x minus 6. Okay, can we factor this by hand? No. Okay, so you really have to keep going until you get it down to x squared. Here, we're going to have to keep going with our list of PRZs. Okay, and here's something that I'm going to write down. Very important note here. Okay. Must use the 0 until it is exhausted. Man, I'm exhausted. Okay, so what does that mean? Very important note. If 1 worked, it might work again. I cannot cross it off the list as being done. You have to use it until it doesn't work anymore. So if you had a number that worked, you must try it again. If it doesn't work this time, then I'll throw it away. Now, which coefficients are you going to use? Okay, we're not going to use the original coefficients. Take a look over here. I have f of x, and he's already broken down into x minus 1. What I need to do now is take this cubic, and I need to separate this one into x and x squared. You need to break the cubic down. If I write the coefficients for the quartic again, it's like I'm starting the problem all over again, and I would have one factor and then a cubic. Okay, you don't want to start all over again. So you must use it until it's exhausted. When you find a 0, continue with the new coefficients. Continue with the new coefficients. Okay, so I'm going to use these numbers here. 1, 0, negative 7, negative 6. And let's see if 1 works again. Drop it down 1, 1, 1, 1, negative 6. Nope, did not work. Okay, so you can officially cross 1 off the list of numbers to try. Let's move on to negative 1. Let's try negative 1, but I'm going to use the coefficients from that cubic again. It's like we're now working on the cubic. Okay, And every time you find a number that works, it's going to get smaller and smaller. So I've got 1, negative 1, negative 1, positive 1, negative 6, positive 6. We found a winner. We found a winner. So if you look at this cubic up here, I have broken up the cubic into the linear factor x plus 1, and here's the quadratic, x squared minus x minus 6. Okay, we're getting there, but we're not done, because now I have a quadratic. Okay, and the fastest thing to do when you get it down to a quadratic is factor. Okay, so you pray for quadratics so that you could factor. Did you know that you'd get to the point where you'd pray for factoring? X plus 1. Let's see, x and x. How do you make a 6? 1 and 6, 2 and 3. I think it's going to be a 2 and a 3. I think it's going to be plus 2 minus 3. F of x is in factored form. Let's take a look at this here. F of x started out as x to the 4th. F of x here is x to the 4th. F of x here is 1, 2, 3, x to the 4th. Every time I write f of x, he's an x to the 4th. If you ever write down something where f of x is suddenly just a parabola or just a cubic, that is not good writing, and you will lose points. So make sure he's complete every time. Let's draw a graph of this polynomial. So it needs to touch the x-axis at positive 1, negative 1, negative 2, positive 3. How about a y-intercept? The y-intercept, I always like to look back at the standard form. It's positive 6. Okay, so I know where to cross the y-axis. This is an x to the 4th, so it's going to go up, up. And since it's multiplicity 1, 1, 1, it's going to cross, cross, cross. Here we go. Cross, cross. Grab that. Cross, cross, up, up. Perfect. Okay, by the end of the chapter, graphing the polynomials should be pretty easy since we're doing it so much. All right, let's do another one. PRZs. Here we go. PRZs. Sometimes people ask me, well, can we just factor outright? Sure, but this one has 5 terms, so I don't think we can factor, even by grouping. Okay, but always stop and ask yourself, can I factor? So the PRZs, looking at 24, are 1 plus minus 2, 3, 4, 5 doesn't go in, but 6 does. Okay, now let me tell you a trick. When you get to the halfway point, because 4 times 6 makes 24. Okay, you could just bring it on back. So what number goes with 3? Plus minus 8. What number goes with 2? Plus minus 12. Plus minus 24. So when you get to the halfway point, you just need to find all of their matches. Okay, and let's try a 1. The coefficients are 1, 1, negative 2, 4, negative 24. Does it work? 1, 1, 2, 2, 0, 0, 4. Nope, didn't work. If it didn't work now, it's never going to work. Let's try negative 1. Same coefficients as before. And we've got a 1, negative 1, 0, 0, negative 2, positive 2. 6 times, oh, didn't work. Okay, so there's no way the 1s are going to work. It's time to move on to the 2s. I always start with the positive 1, as do most people. Let's see if this one works. Drop it down 1, 2, 3, 6, 4, 8, 12, 24. It worked. What are you supposed to do as soon as something works? You're supposed to write f of x in factored form. The factor is x minus 2. This was x to the 4th, but we got it down to x cubed plus 3x squared plus 4x plus 12. Okay, I guess we should continue on with the PRZ madness, right? No. Is there any other way you could get this factored? Because if you have a better way, we should probably go with that. Can we do grouping here? This group and this group. I think we can. At this point, I want you to put some big brackets around the two that we're going to be working on. F of x needs to have all the rest of the equation here written down, but I'm not going to be doing any work with it. I'm going to focus here inside of the brackets. Okay, I'm going to take out an x squared, leaving us with x plus 3. Here, let's take out plus 4, leaving us with x plus 3. You have to put a plus. These two things plus these two things are those 4 things. So what are we down to now? X minus 2, x squared plus 4, and x plus 3. How does that factor? It doesn't. It doesn't. So this is as much as we can do. This is factored form. So when we go to look at the graph here, it's only going to touch at 2 and negative 3. How about the end behavior? Remember how to write that? The end behavior here, if we look at the problem, is y equals x to the 4th. So we're going to need to have our graph going up, up. The y-intercept is, what is it? Negative 24. So let's make sure that we have a negative 24 for the y-intercept, and here we go. We're going to cross. There might be a curve somewhere, I'm not really sure. We're going to cross, cross. I know it's not going to look like a parabola. Right here, if this arch came up and touched the axis 2 times, I'd have 2 more x-intercepts, and that would be from that quantity right there. But he says no more. Okay, we got one more. Got this last one right here. It looks like the PRZ list is going to be rather small. PRZ list is plus minus 1 divided by plus minus 1. So I think I'll try a 1. 1, negative 3, negative 5, negative 1. Does it work? 1, 1, negative 2, negative 2, negative... No. All right, well, I hope negative 1 works. 1, negative 3, negative 5, negative 1. So 1, negative 1, negative 4, positive 4, positive. It worked. So f of x, which started off as a cubic, is now down to x plus 1, x squared minus 4x minus 1. Okay, can we factor this by hand? The only way to make a 1 is 1 and 1. So now the question is, how are we going to deal with this if it doesn't factor? If it doesn't factor, guess what? We're going to use the quadratic formula. That's right. Okay, so let's come over here. The quadratic formula says x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Got it. Now let's do the calculations here. I've got 4 plus and minus, cancel. What is that? Radical 20 all over 2. All over 2. I have to simplify that radical a little bit. So let's see. Who is going to get divided by 2? Well, I think they're both going to get divided by 2, right? So the 4 is going to get divided by 2. And then radical 20 is 2 radical 5. And he is going to get divided by 2. They each get the denominator. And what I really want to do here, let's see, x equals 2 plus or minus radical 5 is write these factors, okay, separate. Okay, separate the zeros. It's going to be easier when you write your final answer. So x equals 2 plus radical 5, and then we have x equals 2 minus radical 5. Okay, now it's time to write the answer. F of x equals, where did we go up here? We have x plus 1. And I know I have 2 factors. You have to be very careful here. Here's where the answer is going to go. When we found negative 1, look what we said. We said plus 1. You have to change the sign. So here, start off with an x. It's going to have a lot of things. It's going to have 3 terms. So which sign do we change? We have to change both of them. We're going to say x minus 2. But then you have to say minus radical 5. You have to change. You have to minus both of those things. Let's do it again. X, say minus 2, but then say plus radical 5. Look at that. You can even use the quadratic formula if you need to, but you got to get that thing factored all the way. All right, well, let's draw a graph real fast. Let's draw a graph. So it's going to touch the x-axis at -1. It's going to touch the x-axis at 2 minus radical 5, and it's going to touch at 2 plus radical 5. The y-intercept is -1, and it's a cubic, so it's going to cross, cross, cross. I can't wait to try some of these with you tomorrow.